In most of the time in many books, the proof of different rules that are not given. So what you can do, you can watch throughout the video and understand how to prove the sine rule. Let's understand what is sine rule. So if I'm writing A by sine A, that is equal to B by sine B, that is equal to C by sine C, and this one is equal to 2r, which is 2r is the capital radius, or we can say circumradius. Now I will take three types of triangle whenever we are proving the sine rule. First triangle that we are taking as this triangle is ABC, and here the condition that is given that this A is less than pi by 2 and which is greater than 0. This is also obvious thing, because if I'm writing less than 0 value, this is not possible because degree is there, because so we will say A is less than pi by 2. And I am drawing on another triangle. I am writing this one as D, and this CD is passing through the center that is given as O. Now what we can understand from here, if we will see this triangle and the angle of this, we will say this one is theta, and we can also say this one is also equal to theta. Why these two angles are equal to theta? Because the angle subtended by the same points are equal. This is the property that we had learned in grade 9th and 10th. So we can say angle CAB that is equal to angle CDB. Done. Now let's discuss about the triangle DCB. I will write here the value as sine theta. Sine theta here can be written as equal to, so firstly you have to understand whether this triangle is a right angle triangle or not. So what we will do, we will see this is the say like this is the chord that is passing through center, which means that I will say this is equal to r, this is equal to r, which means that this will be the diameter. And if any triangle that is passing through the diameter, we will say the angle that is subtending by the semicircle is equal to 90 degree. So what we can see, this triangle is a right angle triangle, which means that we can find the sine theta clearly from here. So sine theta can be written as perpendicular. Perpendicular will be CB hypotenuse, that is equal to 2r. Write the same sine theta for the next angle that is given as this one. Here you will say sine theta. Also write this sine theta as sine of A, that is equal to CB upon 2r. If I want to find the distance of the CB, I will write it as equal to A. Okay, so which means that you will say the value of 2r can be written as A by sine A. Similarly, we can also prove this is equal to B by sine B, and we can also prove this one as equal to C by sine C. Move on to the second triangle, in which the triangle is clearly given as ABC, and this triangle is a right angle triangle. Why? Because this one is AB is passing through center, and we can say this one is a diameter, which means that this angle is equal to 90 degree. Now if I want to find this angle that is given as sine A can be written as perpendicular. Perpendicular is equal nothing but that is equal to CB, and in hypotenuse you will write as equal to 2r. So you will say CB is equal to A upon 2r, which is equal to sine of A. So you can also write this one as A upon sine A, that is equal to 2r. That's it. This is the formula that you will get. Now let's move on to the third triangle, in which we are having the triangle that is given like this. The triangle in which angle is given greater than 90 degree. So I will write this one is B, this one is A, this one is C, and this one is D. Now we can also see, since all the points are touching on the circle, then we can say this triangle, this shape that we can say that is a cyclic quadrilateral, which means that we can also write angle A plus angle D, that is equal to pi. So we can write the value of angle D that is equal to pi minus of angle A. Now since BCD, so you will write since BCD is a right angle triangle, So you will say right angle triangle. Here you will write equal to particular can be written as BC upon sine BC. BC can be written as A upon sine D. So the value of sine of D also is sine pi minus of A. So you will write this value as A upon sine of A.